Let's solve this pair of simultaneous equations using elimination. Now, I know that I can solve this pair of simultaneous equations by elimination because if you see in these two equations, the coefficient of y is the same. What do I mean by that? Well, you see how you have 2y here and 2y there? The coefficient is the same. The coefficient of y is 2, and it's the same in both equations, right? So I know that I can use the elimination method. Now, the first thing that we do is we label our equations. So let's call this equation 1, and this one will be equation 2. All right. Now, I already see that I'm going to eliminate 2y because there's 2y in equation 1 and 2y in equation 2. Now, since these two signs are the same, it's positive 2 and positive 2. Remember, to eliminate means I want to get to 0, right? So 2 take away 2 gives me 0, all right? An easier way to remember it is just that once you have the same coefficients with the same signs, you can subtract the equations to get rid of that variable. So I want to get rid of 2y. So what I will say is I will say equation 1 take away equation 2. All right. And now I am going to subtract all the corresponding terms. So I'll say 3x take away 2x is just x. And 2y take away 2y is 0. You don't need to write that. And then 5 take away 4 is 1. Oh, that was really simple. Once you have what one of the variables is equal to, like how I have x is equal to 1 now, I can go ahead and substitute x is equal to 1 into any one of the equations. I'm going to do it in equation 1. So I'm going to replace x in equation 1 with 1 because that's what I solved x to be, right? So wherever I have x in equation 1, I'm going to replace it with 1. So this will be, well, 3x literally means 3 times x, so use your brackets, 3 by 1, plus 2y is equal to 5. And now I just solve as I would solve any equation. So 3 times 1 is 3, plus 2y is equal to 5. That means that 2y is equal to 5 take away 3, and therefore 2y is equal to 2. So y is equal to 2 divided by 2, which makes y equal to 1. So the solution of this pair of simultaneous equations will be x is equal to 1 and y is equal to 1. Let's look at another one. So in this one, I have 4x minus 3y is equal to 1, and then 3x minus 3y is also, well, sorry, it's not also, but it's equal to 0. So the first thing that we do is we label our equations. We call this equation 1, and we call this equation 2, right? Now, since the coefficient of y is the same in both equations, look, it's 3, and then also the signs are the same, I can use the elimination method by subtracting, because once you have the same signs and same coefficients, you could just subtract the equations to eliminate that variable. And why it works is because if I say minus 3 take away negative 3, I will get negative 3 plus 3, which is 0. So that's why this will go to 0 when I subtract the two equations. So I go ahead and I say 1 take away 2. That would give me 4x take away 3x is just x. Negative 3y take away negative 3y will give me 0, like I worked it out here already. So that would just go to 0. And then 1 take away 0 is 1. So once you have what x is equal to, you can go ahead and substitute that x is equal to 1 into any one of the equations. Let's say equation 1. And I'm going to replace x with 1. So it'll be 4 times 1 minus 3y is equal to 1. And then I go ahead and solve. So 4 take away 3y is equal to 1. Therefore, negative 3y is equal to 1 take away 4, because I move 4 from this side to the other side, it becomes minus 4. So this will be minus 3y is equal to -3. And therefore, y would be equal to -3 divided by -3. So y is equal to +1. So the solution to this to this pair of simultaneous equations is x is equal to 1 and y is also equal to 1. Here's another one. First things first, we label our equations. This is equation 1 and this is equation 2. All right, we identify already that the two y's in both equations have the same variable 5 and both of them have the same signs. So to get rid of that y, we can go ahead and subtract the two equations, right? So I will say equation 1 take away equation 2. Now it doesn't matter if you did 2 take away 1. The reason I do in 1 take away 2 is because 1 has bigger numbers. So when I subtract 2 from 1, I will get positive numbers. But if I were to subtract 1 from 2, I will get negatives. And I just prefer to work with positives. So 1 take away 2, we say 12x take away 9x is 3x. 5y take away 5y is 0. And then 65 take away 50 is 15, right? So now if 3x is equal to 15, x will be equal to 15 divided by 3, which means that x is equal to 5. Now that we got what x is equal to, we can go ahead and substitute x is equal to 5 into any one of the equations. I'm going to do equation 1. All right, so I replace x with 5, use your brackets. So 12, remember 12x literally means 12 times 5. So 12, and in brackets I put 5, that's what x is, plus 5y is equal to 65. So then 12 times 5 is 60, plus 5y is equal to 65. Therefore, 5y is equal to 65 take away 60, and then 5y would be 5. So y is equal to 5 divided by 5, which makes y equal to 1. So the solution of this quadratic would be x is equal to 5 and y is equal to 1. Okay, check out this example now. It's no different from the others in terms of we have 2x in equation 1 and 2x in equation 2, but the signs are different. It's minus 2x in equation 1 and plus 2x in equation 2. Now, the whole point of elimination is to get rid of that variable that has the same coefficient. To get rid of minus 2 and plus 2, well, I can add them because minus 2 plus 2 is actually equal to 0, and that's the objective. So, therefore, I would have to add the two equations. When you have different signs in the two equations, you have to add them. Unlike the other examples where we minus, we have to add this sign. So, as usual, the first thing that we will do is we will label our equations. So, I would label equation 1 and then equation 2. All right. And as I have said numerous times, we will add the two equations, right? So equation 1 plus equation 2, I add my corresponding terms. Y plus 3y gives me 4y, minus 2x plus 2x gives me 0. And then 1 plus 19 is 20. So if 4y is equal to 20, y is equal to 20 over 4, 20 divided by 4. So y is equal to 5. And now that I have y is equal to 5, I can substitute that into any one of the equations. So we write substitute y is equal to 5 into equation 1. Could be any one of the equations, right? I choose equation 1. Wherever I have 1, I'm going to replace it with 5. So 5 take away 2x is equal to 1. Now I bring down that minus 2x. I move 5 to the other side. It's plus on the left-hand side. So on the right-hand side, it's going to become minus, right? So I'll have minus 2x is equal to 1 take away 5, which is -4, and therefore x is equal to -4 divided by -2, which will give me +2. So the solution for this pair of simultaneous equations will be x is equal to 2 when y is equal to 5. Okay, let's look at this one. It's 3x minus 4y is equal to -24, and 5x plus 4y is equal to 24. We have different signs and the same coefficient. So we know that when we have different signs, we add the equations, right? Because -4 plus 4 will give me 0. So I go ahead and I label my equations, equation 1 and equation 2. Now you have to do this all the time, huh? All right, so let's go ahead and add the two equations. So we say equation 1 plus equation 2. Well, 3x plus 5x is 8x, and -4 plus 4 will go to 0, which we are trying to do, and -24 plus 24 is actually also equal to 0. So if 8x is equal to 0, x will be equal to 0 as well. So now we substitute x is equal to 0 into any one of the equations. I'm going to do it in equation 2. Wherever I have x, I'm going to replace it with 0. So 5 times 0 plus 4y is equal to 24. 5 times 0 is 0. 4y, we bring that down, is equal to 24. Well, if 4y is equal to 24, y is equal to 24 divided by 4, which means that y is 6. So the solution to this pair of simultaneous equations is x is equal to 0 when y is equal to 6. Let me show you how to check if your solution is correct. To check if your solution is correct, you substitute the solution that you get, like what you get for x and what you get for y, into both equations. So here, x is 1 and y is also 1. So let's see. If I replace x with 1, I'll get 3 by 1 plus 2 by 1 because y is also 1, and 3 plus 2 is equal to 5, so it correctly substitutes in equation 1. Let's check equation 2 now. 2 times 1, so I put 2 by 1 plus 2 by 1 as well, and that would give me 2 by 1 is 2 and 2 by 1 is 2, so 2 plus 2 is 4. You see that it substitutes correctly into both equations. That means the solution is correct. Let's look at another one. The second equation that we did, we got the answer as x as 1 and y as 1 as well. So substituting into the equations, we get 4 by 1 minus 3 by 1, which gives me 4 minus 3, which is 1. So it correctly works out in equation 1. Now for equation 2, 3 by 1 minus 3 by 1, well, 3 minus 3 is 0. So it works out. The solution is correct. The next question that we did, let's see, our solution is x is 5 and y is 1. So let's substitute into the two equations. 12 by x is 5, so 12 by 5 plus 5 by y is 1, so 5 by 1. That would give me 12 5 is 60 plus 5 is 65. It works in equation 1. Let's see equation 2 now. 9 by 5 plus 5 by 1. 9 5s are 45. 5 by 1 is 5. So 45 plus 5 is 50. It works out. So this solution is correct. The next one, our solutions were x is 2 and y is 5. So substituting into the equations, in equation 1, it will be 5 take away 2 by 2, which is 1. 5 take away 4, which is 1. And then in equation 2, we have 3 by 5 plus 2 by 2. 3 by 5 is 15 plus 4 is 19. My solution works out. That answer is correct. And the last one that we did, our solution was x is 0 and y is 6. So let's substitute 3 by 0 minus 4 by 6 will give me, well, 3 by 0 is 0 minus 24 will give me negative 24. It works in equation 1. And then in equation 2, 5 by 0 plus 4 by 6. 5 by 0 is 0, 4 by 6 is 24. So 0 plus 24 is 24. That solution is correct. So that's how you check to see if your solution is correct, by replacing the values into both equations.